So let's look at another thing involving circles. Let's talk about the area of a circle. Remember, area is how many squares are inside a circle. But notice how a circle does not have edges. So, excuse me here. So it's a little harder to determine the area of a circle since it doesn't have edges. So one things we can do is, and we'll use this little geo tool here. See if I can get this to work here. So looking at area circles, so one thing we do know that if you go from here all the way around the circle, that's described as the circumference. So let's straighten this out. So do you recall the formula to find the circumference of a circle? So you should recall that that's going to be 2 times pi r. Okay. Now, what we could do now, though, is we still want to find how much space is inside the circle. To find out how much space is inside the circle, there's a little thing we can do here. Let me just get this around here. We can get to see things. We can what we call dissect, which means cut it up into little bitty sectors. So right now, notice how these little bitty pie shaped or pizza shaped sectors represent the area of the circle. But we still don't really have a great formula to define these little areas of these little sectors either, because they're still not squares, so it makes it a little bit hard. Notice that I could increase the number of pieces I cut it into. So let's say we cut it into 20. Now, one of the things I can do is I can rearrange the shapes. So I could kind of like slice this up like you do a pizza. I can kind of lay these pizzas out. But then what I can do is lay one of them back over the other like this. Notice I transform the shape, but does it take on a shape that we're more familiar with? Okay. Now, suppose we change this to more pieces. As I change it to more and more pieces, what are we starting to see the shape turn into? So as I get more and more pieces, it starts to become more vertical. So what we can do is use this shape as a way to approximate the area of a circle. So since we recognize that this shape is a rectangle, we know that the rectangle we have length times width. So notice that R is going to be the width, but what's going to be the length? Well, remember, if we take this back apart, let's see if I can get this to work for us here. If I slide this back apart, remember, this distance here was the circumference. So notice that half the circumference is on the bottom of the rectangle and half of the circumference is on the top of the rectangle. So when I put this all back together, notice that the length is actually half of the circumference. So if we divide 2 pi r, oops, thought I got that thing to work. So try that again. So if we have 2 pi r and we divide that by 2, notice that the 2's will divide out. So that means what's going to represent the length? Such that pi r is going to represent the length. So what we can do is use this formula to approximate the area of a rectangle. So the area of a rectangle, and we're going to just use the equal sign here because it's going to be close enough that we're going to say it's equal. So area of the of the circle is actually the same thing as multiplying the radius times this pi r because this rectangle represents the same amount of space as in the circle itself. So if I multiply this pi r times r, notice that if you have an r times r, that means there's two r's connected to multiple locations, so you can write this as pi r squared. So we can create a formula to determine the area of a circle. Now remember, for us, we're going to be using pi as approximately this 3.14. So if it asks us to substitute in, we can substitute in 3.14 to determine the approximate area of a circle. So, so notice that we'll get rid of this as well here. So in our problem, notice that a circle can be transformed into a rectangle or a parallelogram, if you will. But notice how this radius is actually going to become a height as I cut it more and more pieces. So the area is going to be this pi r squared. So got another little stray pi r there. Go away. There we go. So if I know the radius of a circle, then I can determine the area of a circle. So if I say the radius is, say, 5, what I can do then is say, hey, the area of a circle is going to be this pi times this radius squared, if you will. And we know that we can replace the pi with 3.14. I'm going to use parentheses for multiplication. And I'm going to replace this r with a 5, and I have this 5 squared. So basically what we have then is this 3.14 times this 25. Now to expedite the math, we can use a calculator. So if we go 3.14 times 25, this will give me the area of the circle. So this goes out to the tens place. So our area is going to be about, if you will, 78.5 square units. So if I say that was 5 centimeters, then the area of the circle is going to be 78.5 square centimeters. So we write this as that. So what this means is if I construct a circle with a radius of 5 and I cut it up into squares, there's approximately going to be 78.5 squares inside that circle that are a centimeter by a centimeter in dimension. So hopefully you find that kind of useful in finding the area of a circle. So it's kind of using a little bit of creativity to develop a formula that allows us to do this algebraically with the formula.